Hello friends, today we will discuss about UDP, what is the difference between UDP and TCP, then we will discuss about the applications of UDP and TCP, and then we will describe an example of UDP with the help of a program. Myself Sanjay Kumar Das, a technology expert with more than 10 years of experience, I welcome you to my channel Canny Information Center. Let's begin. What is UDP? UDP is basically User Datagram Protocol. It stays at layer 4 of OSI layer. So there is basically two types of protocol used in layer 4, that is TCP and that is UDP. Right. In UDP, it is a connectionless protocol where there is no connection that needs to be established between server and client before sending or receiving any data. It is enough for UDP to just create a socket and then bind it to the address, and then they can do the send and receive operation. The only difference in send and receive operation between TCP and UDP is in UDP you have to send an additional parameter where for each send operation you have to specify the address where you want to send that data. Since you are not creating a connection, so every time you have to send that address along with the send or receive request. Now let's talk about the real-time examples of UDP and TCP. First we will talk about TCP. As you know, in TCP, all packets needs to be acknowledged. For example, for any banking transactions or any websites mostly, do you think if you are going to deposit or if you are doing some transaction in a banking application, do you think you need an acknowledgement for any transaction? Of course, yes, right? Because you want 100% surety that transaction happened or not. Similarly, for a website, whenever it wants some page from a server, it needs that page 100%. And now, since it's a one-time operation they are doing and they want the accuracy of the result, that's the reason why they use TCP here, because every packet will be acknowledged. Now, let's come to real-time example of UDP. In UDP, it doesn't care much about the acknowledgement part. It cares more about the speed, efficiency. So let's take some example. For example, a video streamer, network video streamer. So what happens in that? For each video, as you know, it is a collection of different frames, right? So there are, like, for example, 30 frames coming per second to your application which is streaming that video. Now, for example, one frame is dropped. Do you care about that really? No, right? Because you want to see that video without lag and you want to see that video continuously. Even if one frame is dropped, you don't care, and anyway, like, next frame is going to come and you can watch the full video continuously. Think of an option where each video packet or each video frame has to be acknowledged. So every time a frame comes to the tool or video player, it will acknowledge, and then again the next frame will come. So that will be more, it will introduce more network latency, as well it will not have that much amount of video efficiency in terms of playing in a network. It may lag. Let's take another example. For example, a weather forecasting system. For example, there is a server, central entity, to which all the countries are sending their weather report to. Okay. Now all the countries will have a client. They will send their weather report to the server, right, periodically. For example, every 10 seconds. For example, one country was not able to send its data to the server. Then, is it a big deal? Obviously no, because anyway you know that that data will again come after 10 seconds. So you are not worried too much about the acknowledgement part or the accuracy of whether the data reached your place or not, right? So in this case also you can use UDP to reduce the network latency or network bandwidth without the need of acknowledgement. Now let's take this weather forecasting as an example, and now let's understand the operations involved in this client and server, and let's code it in a very simple way and try to make you understand how UDP works. So in TCP server, we have seen the states goes like socket creation, then bind, then listen, after that accept, and then send
or receive, right? Similarly, in case of client, it is socket creation, then connect, after that send or receive, isn't it? So this was in case of TCP. In case of UDP, there are few steps that will be omitted, that is listen and accept in server, and in client connect, because this three things takes care of the TCP handshake overload and establish a connection between client and server. But since UDP is connectionless, we do not need a connection to be created. So you just need to create a socket, bind it, and then do this. Now we'll write a client server program for a weather report. Weather report. So for this, there will be a server and there can be multiple clients. For our purpose, we will take only one client sending weather report for multiple countries. So client will send a store data request with what data? Country code as 1 and country name is India, and for example temperature is 55. This much amount of data the client is going to send to server, and server is going to store it in its DB in some form, whether it is tree form, whether it is in memory array, or it is in database, whatever it is. Now the server is going to send an acknowledgement response to the client that yes, I have stored the data. Now another type of request that client can send is read data. Read data. That is, it wants to read the data of country code 1, that is India country code. Then server will reply back with same read data by filling up. It will see this country code 1, it will see its own DB and check whether this value is already stored in its DB. If it is there, then it will return back with 1 India 55 data to the client. And what client will do? Client will print that today. So it will print country India temperature 30 degree or 55 is what was stored, so 55 degrees Celsius, right? If any other invalid country you will give, then it will return back something null, country empty and temperature also empty, something like this. So these are the operations that are supported by the server and client. So today we will write the code to simulate this in a better way. Let's see. For showing this UDP example, today we have taken a machine called Ubuntu, that is Linux based. You can take any Linux based machine, that should work fine. So let's first write a header file that will be included in both server and client, and it will have all the common stuffs that will be needed by both the programs, reducing the redundancy. Let's create a folder first, mkdir udp vim udp header.h. Here first we will list down all the header files that are necessary for this program. Now we have listed down the header files. Let's define the server port on which we are going to work on. Server port, let's take a unique number, for example 9876. Has define this. Let's now define the operations that can be performed by either server or client. Now server can store data or client can ask the server to store data. So let's take store data is the first enum. Second operation can be read data. Third operation can be if you send some data from the client to the server, server should acknowledge or response. So let's take response as one operation. If you push some invalid data, for example, take invalid data as another enum, and quit. So we have just taken for safety, few enums that we'll use in our program. Now let's take only few countries, 4 to 5 countries, for which we will store the temperature and then we will fetch the data from the server. Now let's take an enum country. So we'll try to assign unique identifier to each country, or we can say it is a country code, and this country code will only be used for a kind of unique identification within your own program. It doesn't have any relevance out of this program. For example, India, US, UK, and then Japan, for example, China. Let's keep this much. Now we'll craft the data that we will send from the server to client or client to server. That data should have some format, or that message should have some format. Let's define that format or structure. Type def struct message. So what kind of data is coming? So like the operation is store data, we can treat it as a message ID, either store data or read data. So it should have a message ID. So let's take uint 8_t message ID, and then we can refer something called as data, right? Now data here can be composite. For when I say composite, I meant the data, it can have a country code, and the data can have the country name, the data can have the temperature detail. So it's like a composite data per message. So we'll construct another structure for the data itself. Let's message. Now here we'll define type def data struct data. Now data, as I said, there can be country code. Let's take uint 8_t country code. Second can be character, country or country name or country, let's take 64 as max. Then it is the temperature, character, temperature, let's take it as a character thing, and we'll store it in Celsius. Okay, now we are pretty much done with the header file, which is having the definition of our message, which is having the necessary enums, and which is having the necessary header file. So now all these things, you need not have to write it again in client program as well as server program. We can just include this file in the client program or the server program. Now let's go ahead and write the server program. Server.c. First thing that we will do is first include udp header.h. We included that header file. Now I'll start the int main function. So now first thing we need to do is create a socket. Int sock fd, create a socket. Sock fd equal to socket af_inet. This means IPv4 socket we are creating. Now in case of TCP, you saw the second argument was sock_stream. That indicates it's a TCP socket. But in case of UDP socket, it is sock
underscore dgram, which indicates it is a UDP socket. And the third argument is protocol type. Here we specify 0, that means it is unspecified. Whatever protocol type is going to come, we will accept it. Now with this, I'll just put a safety check. Now we have created the socket. Now we will kind of specify the server address to which this socket is going to be bind. Now after binding in TCP, you have seen we were writing an accept call and listen call, that is for waiting for a connection. Since UDP is a connectionless protocol, that's why we will not have any kind of connection here. We'll directly go to the phase where data can be exchanged to and from. For that, in TCP we were using receive and send, or write and read system call. But for UDP we have to use receive from and send to. Why is that? Because in receive from and send to, we specify an additional argument, that is to which server it has to send that data. Since there is no connection established, that's why every time you send a data, you send the server information along with it. And same for the server, whenever it wants to send any data to the client, it has to send the data along with the client address using either send to or receive from. Okay, so now after binding, as I said, it's now ready and we can do any receive call and send call. Now I'll put since it's a server, it should always be running, that's why I'll put a while loop here. Now inside this while loop, it will wait for requests. Now we'll use which call? Receive from. Receive from will return the number of bytes read. So let's declare another variable. So here num bytes equal to receive from sock ft comma, here we need to pass the buffer in which we want to receive that message. So what is our message structure defined here? Message structure is like this. So this struct, we have to create object of that struct, message, receive message, and we'll create send message. Okay, now when we are receiving here, we'll use receive message, receive message, and pass the length also, size of receive message. Okay, and then 0 struct sock addr struct ampersand client addr. Now this client addr is not filled before this call. So whenever a client sends some data and it captures using receive from, this client addr will also be filled with the client IP address and port number, client address basically. Okay, and also the size of the client address, ampersand client addr len, put as receive field. Fine enough. Continue. We do not want to exit it at this point of time. Close sock ft return 0. Okay, now inside this while, once you receive some message, what you are going to do? If you received successfully, then either that receive message should contain either store data or read data. That is the two operation that we are talking about right now. So write a switch case. Now in case of store data, whatever data we receive from the client, we are just going to store it. Now for storing, as I said, we can either use linked list or we can create a simple array to store the data, and we know the format of the data. As we saw here, the data format is like this. So you can create an array of this data and we can arrange the data in index wise. So whatever is the country code in that index, that country code data will be present. Okay. So let me define a data store. Data store of 32, for example. You see here, data is this structure. I created an array of 32. Whatever index it will point, that will be the country code. We are assuming that. It is a very simple way of storing. Now in the store data, we'll store it like data store receive message dot data dot country code equal to receive message dot data. You got this line? So whatever country code the client has sent, in that index we are storing the data part. Okay. Now we have to acknowledge to the client that we have received the data. So just do a send to. If so, before that so the message that get exchanged between client to server and server to client, the format is same. So while giving a response, the message ID should be, when it sent us the data, it sent us using message ID store data. Now we will send it to the client using message ID response. So send message dot message ID equal to response. Okay. Now you do not have to fill the complete data here, because just seeing this response, client is going to understand. Now if send to now store data part is over. Now let's come to the read data part. So whatever client is going to query for the temperature record of the server from the server is going to revert back with that. Now here the responsibility of client is to at least send the country code in the message, so that we can query our data store and send back the country details including the temperature. Let's write the code for that. So while sending the data, send message dot message ID equal to, what should be the message ID here is read data. Whatever client has sent us, we will revert back with the same message ID. And of course we are going to also populate the data part, that is send message dot data equal to data store of receive message dot data dot country code. You got this? You fetch whatever you received from the client, you fetch that index data from your data store and assign it to data, and now you are going to send this send message using send to call. I hope you understand. Now the send to code is same, so I'll just copy paste it. Let's just compile this code once. UDP gcc-o server.c. Okay, it is Sauclen _t. we made some mistake here, sockline underscore t. Okay, now it's compiled, server code is ready. Now let's write the client code. Now let's take the client example. We can just copy the server.program to client.c and then remove whatever is not needed, client.c. So till this part, socket creation and this address thing is also same, because it's the same machine where we are trying to communicate. Bind is what is not needed for a client. We'll remove this. Let's remove this client editor alien and whatever is written inside a while loop. Now the client has two responsibility, as we said. It has to send, store data, come to the server with the information required, and it will request from the server using read data. So there are essentially these two operations. So in this while loop, we can ask the user for the type of operation that he wants to do, whether he wants to store data or he wants to read the data. Now based on this option that is given, if option equal to store data, then you need to do some operation, right? Else if option equal to read data, they need to do something. Okay, else if anything else comes, then it's like invalid option. Okay, now in send, what data you have to send, what kind of, now in the send, now in store data, what kind of data you want the server to store. You have to craft that message, right? First thing is you have to assign the message ID here. So send message dot message ID equal to store data. You have to send this. Second thing is you have to populate the send message dot data part, right? So for that you need to ask the client which data you want to store, right? For example, let's give the user the flexibility to store whichever country's temperature he wants to set. Now whatever country code has been set here, or whatever country code the user wants to provide the data to the server, let's also populate the name of that country. Okay, let's end this switch case here. Now we have set up in the data part, we have set up the country code as an input, then we have set up the country as a string, right? What is remaining is the temperature. That varies, so let's take it from as an input from the user. Now we are done with the data part. All the three elements have been filled up. Now you can send it. Now if you go here to the top, here there was sock length, client ADDR length for server part. For client we will make it ADDR length. Okay, now ADDR length equal to sock length of T size of struct sock ADDR. Now what you can do, we'll send the message, right? We'll do one thing, we'll just copy this, we'll copy this, send to thing from here, from the server that we wrote to here. Now what we're going to change here is, instead of client address, we don't need a client address, instead of that we'll have is address, we'll use ADDR len, ADDR len. Okay, data send field. Okay, so now you have sent the data from the client to the server. Now let's go to the server program here. Here what we're doing, so here once we receive the stored data from the client that we just crafted, after that it is sending some data as an acknowledgement. So let's write the code to receive that acknowledgement. So it is the same thing. Let's copy this receive from call here, address, and this is like ADDR length. Now we have written the code for storing data. So whatever data the user has given as an input, that we are sending to the server, and whatever server replies as an acknowledgement we are receiving here. Okay, now we will write the code for read data here. So in read data, as I said, a client has to at least fill up the message ID of the message part and the country code, so that rest of the things can be filled up by the server and sent to the client. So once the client receives that data, we will print it on the client. Okay, let's write it. Integer country code send message dot message ID equal to read data. Okay, put as, let's enter the city thing. Let's copy this 1 2 3 4 5 6 7 7YY 7YY, paste it here. Now what we can do here is we can scan for that data. Scanf %u unsigned star ampersand send message dot data dot country code. Okay, we filled up the country code here and we filled up the message ID here. Now you can send this request to the server, so that server can fill it up and send it back. Let's send it. Let's copy this thing 4 send and receive. So this should be the same thing. 1 2 3 4 5 6 7 8. So 8 YY, copy and paste it. Okay, now you send the message to the server and server received something. Okay, now if it receives successfully, we can print it, right? Same thing, we can write it here. If message id equal to response printf data stored successfully, or you can simply write acknowledgement received. Because if you go to the server code here after storing, we are reverting back with message id response. That's the reason I have put a check here so that you can see. Okay, now I think pretty much we are done with the client program as well. Let's compile the client program here as well. Let's compile. Server is compiling fine. client.c USA. What is okay, here it is US. Okay, let's make it USA here. Mem cpy string dot h, isn't it here? No, has include string dot h. Great. So now in TCP you have seen first the server has to be alive, then you bring up the client so that client makes a connection. But in UDP it is not like that. In UDP you can run the client first, then after the server comes up, then also the client can send data, because there is no connection oriented thing between client and server. So whoever comes first, it doesn't make any difference in UDP. But in TCP always the server has to be alive first so that client can start a connection initially. Initially client has to initiate, but here it's not the same. Okay, now let's run these two programs. Dot slash server. Okay, it's waiting for request. Dot slash client. Okay, here what option you want to do? First you want to store. Of course if you read something it is of no use. Okay, now here you have, for example, for where UK, for UK I choose the temperature to be 45 degrees Celsius. Now again I want to store some data, so, and for example for China it is 55 degrees Celsius. Now if you see here, all acknowledgement are getting sent, and here if you see, acknowledgement are getting received as per the code that we saw. Okay, now you want to read the data. If you go here, which country you want to read the data? For India. Of course you have not set the data, so there will be no information available. So if you see here, the country is null and temperature is null, but whatever you have set, if you want to see the read data, and then for example UK number 3, you see here whatever you have stored the data, you can fetch it. So this is the program about. Now again we will read something. Let's say China. You see whatever we have set, that temperature coming. So this is about this UDP programming, but I'll suggest if you have any doubts, you probably go through this video once again and pause in between, understand that code, and then go further. I understand it has been a very long video, but I also hope that you would have understood something out of this video. It was pretty useful for you. and I will keep bringing up this kind of topics on sockets in my upcoming videos. So keep watching. That's it for today. If you like my video, please give a big thumbs up, share it as much as possible, subscribe it if you have not subscribed it yet, and please don't forget to hit the bell button.